So for our deep dive today, we are looking at a system that is, well, basically being built right now from the ground up. We're talking about Healthcare 4.0,
That's right.
the whole tech stack that's designed to secure the future of medicine. We're talking 5G, the Internet of Medical Things, AI, and of course, blockchain.
Exactly. And we're going to pull out the core ideas from our source material on how all of this is coming together to really completely redesign how healthcare gets delivered.
And it's not just about making things a bit faster, is it?
No, not at all. It's about solving this fundamental problem of just this massive sensitive data load that you get from millions of connected devices. And doing it all while, avoiding the big failures of the old centralized ways of doing things.
Okay, let's unpack this. Before we get to all the shiny new tech, we really have to start with the problem itself. Why is the current traditional healthcare model so broken?
Because it's antiquated.
Right.
It's complicated, and it is desperately, desperately costly. One of the biggest failures is just, the complexity of the system.
Still so much paper.
Oh, absolutely. A lot of major health facilities still rely heavily on paper records or these ancient legacy systems that just can't talk to each other. I mean, just think about the nightmare of trying to move paper reports between different specialists or even across state lines.
And the major failing here, it seems, is that the quality of care you get is still pretty much determined by your zip code, right?
100%. The system has these huge geographic and economic gaps. If you live in a big city, you generally get fast, high-quality access.
Sure.
But if you're in a more remote or a rural area, you really struggle. Your sources point out that this is made even worse by just a basic resource shortage. Some regions have as few as, 22 skilled health workers per 10,000 people? The old systems just don't scale.
It sounds like the big promise of Healthcare 4.0 then is really about democratizing access. It's not just about making a hospital run a bit smoother.
That's it, exactly. Yeah. And to bridge those gaps, you first need a really solid foundation. And that foundation is 5G connectivity.
Right. 5G is the enabler. It's the superhighway that all this medical data needs to travel on.
Yeah.
What kind of numbers are we talking about that make it such a game changer compared to, say, 4G?
The jump is it's dramatic. 5G is expected to be around 40 to 50 times faster than 4G.
Yeah.
We're talking about really high data rates, maybe peaking at 20 gigabits per second.
Wow.
But the critical part is the incredibly low latency and the high mobility. It can support speeds up to 500 kilometers an hour.
That low latency is the key, isn't it? Because in medicine, milliseconds actually matter.
They really do. That speed and that response time, it's not just for streaming Netflix. It enables services that were basically impossible outside of a hospital operating room.
Like what?
Well, critical things like remote diagnosis, high-def video consultations, and continuous remote patient monitoring. That last one is huge for managing chronic diseases without forcing the patient to travel all the time. 5G basically virtualizes the entire care system.
But as soon as you connect millions, maybe billions of sensors and wearables, what the industry calls the Internet of Medical Things, or IoMT, to that highway, you instantly create a huge processing problem. And that brings us to our first segment, this IoMT Data Tsunami and the security cliff.
And that's where the real challenge starts. IoMT devices are just constantly generating these huge volumes of data. Your sources describe this big health data using the 4 Vs. We all know volume, the sheer amount of it. Then you've got variety.
Which is all the different types of data, right? Structured, unstructured.
Exactly. Everything from a clean clinical record to unstructured things like a high-res MRI or genomics data.
And the last 2 Vs are about speed and trust.
Right. Velocity is the real-time speed that data is pouring in from these devices, like from a continuous heart monitor. And finally, veracity, which is just making sure the data is accurate and trustworthy, which is, everything when it comes to medical treatment.
So when you have that much sensitive data flooding in, you have to make some tough calls about where you're going to keep it. The sources note that the old school storage solutions and databases are just, well, they're breaking under the strain.
They are. We're seeing a huge shift in database philosophy. The traditional relational databases, like MySQL, they really struggle because they scale vertically.
What does that mean, Exacts?
Think of it like trying to fit more books into a library by just building a taller and taller skyscraper. Eventually, you just hit a physical limit.
So what's the alternative to that?
The alternative is scaling horizontally. And that's what the non-relational schemaless NoSQL databases do. So instead of one skyscraper, you're building a whole city block of smaller interconnected buildings. They're document-oriented, and they're designed to handle tons of unstructured data really efficiently.
Okay, so whether we store this data flood in a high-speed NoSQL setup or a relational one, the question is, where does the physical storage live? We've got two main options: on-premise, which is local, or using the cloud. What are the big trade-offs there for the listener?
On-premise storage gives you maximum control over security. You're independent from the internet. You're not relying on a third party for security.
But it's expensive.
Very expensive. High maintenance costs. You need a dedicated in-house IT team. That's just not feasible for smaller clinics.
And the cloud. That sounds cheap and easy to scale.
The cloud is incredibly scalable, and it's usually a pay-as-you-go model, which is really attractive. But you're making two huge trade-offs. First, you're totally reliant on an outside company for security. You have to trust them completely with, maybe the most sensitive data imaginable.
And the second trade-off?
You're completely dependent on a constant internet connection. If that connection goes down, your access to critical patient data just stops instantly.
So either way you go, this hyperconnectivity just completely changes the risk profile. This is that security cliff you mentioned.
It is. The sheer number of IoMT devices, from smartwatches to infusion pumps, it just dramatically increases the attack surface for bad actors. Your sources cite a really jarring statistic. 94% of people surveyed believe 5G will make security challenges worse.
94%, that's a huge number. What are the biggest threats these little devices are facing out in the wild?
The threats kind of fall into two buckets: physical and digital. Physical threats include someone actually tweaking or tampering with an IoMT device, especially one that's out in a remote or unsupervised location.
Okay, and the digital ones?
Digital threats are the ones we hear about more often. Things like denial of service or DOS, attacks that just flood a system until it crashes. Or man-in-the-middle attacks that, secretly intercept the communication between a device and the hospital server.
But the real fear, I think, is when the data itself gets compromised and then used to hurt someone.
That is the most critical point. The most common type of privacy violation they identified is medical identity theft. This is where your personal health information is stolen and someone impersonates you for financial gain. And the consequences are just. They go way beyond money. They're life-altering.
Can you walk us through a sort of fictional worst-case scenario where that altered data leads to a life-threatening mistake?
Sure. Imagine a hacker steals your identity, gets some unnecessary prescription filled, and that wrong information gets uploaded to your official file. Later, you have an emergency. If your records have been maliciously changed, maybe showing a drug allergy you don't actually have or a condition you never had.
A rush doctor or even an AI system could make a terrible call.
Exactly. They could give you the wrong treatment or deny a life-saving drug based on that false data. This can lead directly to an incorrect diagnosis, the wrong treatment, and then, all the social and employment problems that come from having your identity stolen.
Which is just unacceptable when you're dealing with life and death information. So if 5G and IoMT created this problem of speed and vulnerability, we need a technology that can guarantee security and trust without creating a new central point of failure.
Right.
This is why we have to move into segment 2, the architecture of trust that comes from blockchain.
Blockchain is the absolute key here because it's a distributed digital public ledger. And what it does is it inherently solves that problem of the single point of failure that centralized systems will always have. You're not relying on one single trusted third party to verify everything.
So if it's peer-to-peer and decentralized, who's managing it? How do you manage all that complexity without a central authority?
That management is actually distributed among all the participants, and it's enforced by consensus algorithms and cryptography. And this distribution of trust gives us the three core characteristics that make it so perfect for healthcare data. First is decentralization.
No bottlenecks.
Right. Second is immutability, and this is vital. Once data is recorded and locked into a block, it cannot be changed, period.
And that's where this avalanche effect comes in, right?
Exactly. Every single block has a unique cryptographic hash, which includes the hash of the block before it. If you change even one single character in an old block, the entire chain of hashes after it becomes invalid instantly.
The avalanche.
It immediately exposes the tampering. And third, auditability. Every single transaction, every patient access request is time-stamped and traceable. It gives regulators total transparency.
We've established the need for decentralization, but how does an organization like a National Health Service actually do this? Do they just hop on the public Bitcoin network, or are there special types of blockchain for this kind of work?
Oh, they absolutely need specialized types. A public blockchain like Bitcoin is totally decentralized, but every transaction is also transparent, which is terrible for private medical data.
Sure.
So instead, healthcare tends to favor two other models. The private blockchain, which has restricted access, and the transactions are secret among known users. That's usually inside one single large organization.
But the perfect setup for sharing data across a whole network of hospitals and clinics must be different.
It is. And that's the consortium or hybrid model. This is where a select group of organizations, say hospitals, labs, insurance companies, share data privately, just among their members. It gives you that decentralized benefit without sacrificing the confidentiality you need to comply with medical privacy laws.
Now, to protect that sensitive patient information even more, blockchain uses some tools that honestly sound like they're from a spy movie. I saw homomorphic encryption in the source material. Can you just break down why processing data while it's still encrypted is such a huge deal for privacy?
Homomorphic encryption, or HE, is brilliant. It solves the analysis problem. See, in the past, to run analytics or machine learning on data, you had to decrypt it first.
And that's your moment of maximum vulnerability.
That's it. He lets you do the processing, run the calculations directly on data while it's still encrypted. The result of the calculation is also still encrypted. The data never sees the light of day.
That completely changes the security model. What about attribute-based encryption, or ABE?
ABE gives you another really fine-grained layer of access control. Think of it like a digital key system where the door doesn't just check if you have a key, it checks if you have the right badge, the right clearance level, the right roll-all before it even lets you read the data.
So you can only decrypt it if your personal attributes match the file's requirements.
Precisely. It allows for extremely specific permissions.
Let's look at a concrete example of how this would all work in practice.
Yeah.
The HealthChain electronic health record system. Where does the massive volume of IoMT data actually go in this scenario? Because a blockchain isn't built to store petabytes of MRI scans.
That's the crucial distinction. Blockchain node storage is limited, so these sensitive, massive data files themselves are stored off-chain. They live in a distributed file system, something like IPFS.
Yeah.
The blockchain doesn't store the huge X-ray files. Instead, it secures the records of where that data is stored, its management hash, and a log of who accessed it and when.
So the blockchain is the immutable ledger that points to the secured data wherever that data lives.
Exactly. The health chain model uses two different chains. A public user chain where users can publish the secure hash addresses of their health data, and then an association-managed dot chain for doctors and clinics to publish their diagnoses and treatment records. The security is in the pointers, not the payload.
This architecture seems to solve the problems of access, speed, and security. So that brings us to the final piece of the puzzle. How do we get value and intelligence from all that securely stored data, which is segment 3, AI and machine learning?
Right. AI and its subfields, machine learning and deep learning, they are the intelligence layer. They take that secure, trustworthy stream of data from the 5G and blockchain infrastructure, and they immediately start automating administration, personalizing treatment, and most powerfully, diagnosing diseases with incredible speed.
And the results we're seeing in early diagnosis they're really impressive.
Take diabetic retinopathy detection. This is the damage to the retina from diabetes, and is often caught way too late. Researchers have used what are called convolutional neural networks, or CNNs, to interpret retinal images and classify them as diabretina, or normal retina.
And the accuracy.
In initial training runs, they were hitting accuracies around 84.21%. That is a really powerful screening tool.
And it goes beyond just a simple yes or no diagnosis. ML can actually classify the type of a chronic condition.
Exactly. ML models can be trained on a whole range of patient symptoms, family history, increased thirst, mood swings, to not just predict if someone might get diabetes, but to classify the specific type 1, type 2, or gestational. And that level of precision lets you create a highly personalized treatment plan much, much faster.
This speed becomes absolutely critical in high-stakes, real-time situations, like a rapid pandemic response. Your sources talk about using AI for COVID-19 detection.
This is where the whole tech chain really proves its worth. Imagine a high-speed 5G network feeding encrypted chest X-ray images into a sophisticated CNN model. That model was shown to achieve exceptionally high accuracy, up to 99.92% in one proposed Model N, telling the difference between COVID-19, bacterial or viral pneumonia, and a normal, healthy lung.
99.92% accuracy is just breathtaking. It completely changes the game for diagnostics. It means you don't have to rely so much on expensive and slow traditional RT-PCR testing.
It does. It dramatically speeds up the initial screening process, especially in low-resource areas, and that allows for earlier detection and isolation. The technology creates a path to affordable, faster testing that can be deployed at scale outside of major labs. It really reduces the burden on overworked healthcare workers.
So, to bring this whole deep dive together, what we're really seeing is a complete integrated ecosystem that's driving the future of medicine.
That's the synthesis. IoMT and 5G give you the real-time speed, the access everywhere, and the continuous flow of data. Blockchain gives you the security, the decentralization, and the immutable ledger you need to keep all that sensitive data trustworthy and private.
And then AI comes in over the top.
And finally, AI and ML provide that crucial intelligence layer for precision diagnosis, personalized treatment, and just making the whole system run more efficiently.
What's really fascinating here is the tangible benefit this provides for you, the individual patient or caregiver. We're moving beyond just hospital efficiency and into a world of autonomous, proactive medical help.
That autonomy is the goal. The system allows for sophisticated machine-to-machine or M2M remote monitoring that can react instantly. Your sources give a great example. A smart contract could be set up to automatically alert a healthcare provider the second a patient's device detects an irregular heartbeat, like atrial fibrillation.
That's incredible, especially for aged, differently abled patients.
It is. It's incredibly useful for anyone who needs constant but non-intrusive observation.
That is truly game-changing. It's a fundamental shift in the quality of life for millions. But now for the final thought, the big external problem that's going to decide whether this incredible system actually succeeds on a global scale.
And that success hinges entirely on one thing: regulation. The technologies we've been talking about, 5G, blockchain, AI, they're all advancing so incredibly fast that the legal and ethical frameworks that are supposed to govern healthcare, like the privacy law, IPRCHIA, are just struggling to keep up.
So the technology is there, but the rule book isn't.
Exactly. The lack of standardized protocols for how these systems talk to each other and just the outdated nature of current laws pose a huge challenge to getting this adopted everywhere. The success of Healthcare 4.0 requires governments and regulators to move just as fast as the innovators. They need to establish new standards and rules to make sure consumer protection and public trust are built right alongside the technology.
Because without that legal and regulatory foundation, it doesn't matter how accurate that 99.92% diagnosis is.
It doesn't. Adoption will be slow, and those geographic disparities we started with will just stay right where they are.